So the next contribution is from Izmir Institute of Technology, Dr. Taygun Uzelli. Taygun Uzelli is an instructor and specialist at Izmir Institute of Technology Integrated Research Center. So the title of his talk will be Structural Controls and Hydrogeochemical Properties of Geothermal Fields in the Varto Region, East Anatolia. Please, Taygun. Okay, microphone is yours.
Thank you, Professor Demir. I think you can see my screen.
Yes, we do see, yeah.
Okay. Good morning, good evening, and good afternoon, ladies and gentlemen. My name is Taygun Uzelli. I'm a PhD lecturer in Izmir Institute of Technology. Firstly, I would like to thank the organizing committee and the editors for organizing this comprehensive and important workshop. Today, I want to provide new data for geothermal systems in Eastern Anatolian region. In my presentation, I'm going to cover 4 major aspects. Firstly, I will briefly introduce you the purpose of the study and the study area. Secondly, I will describe the stratigraphy and the hydrogeology around the Varto region. Then there is a section on structural controls of the geothermal systems of the Varto region. And the last one is the results and the summary. Within the scope of my presentation, I will talk about the findings of my PhD that I completed in 2019 in Hacettepe University. Also, I would like to thank the Muş Alparslan University, Eastern Anatolian Development Agency, Muş Governorship, and Varto District Governorship for their support throughout the study. There are some important questions we asked ourselves before starting this study. These are why we choose geothermal energy and why in this area. So we concentrated on the eastern side of the country, not the west side of the country. So there are some questions like which structural element controls which geothermal source. I think the most important answer to these questions is our current economical situation in Turkey. So we must reduce the energy import of our country and support and use of the domestic and renewable energy sources. You know, in the last 10 years, we reached the 4th place in the geothermal electricity production in the world with some government incentives and some participation of the private sector. However, as you see from the map, almost all of the existing geothermal electricity power plants are located and concentrated on the western side of the country. So this situation started to cause some public reaction with some technical problems, environmental problems. For this reason, we think that the geothermal electricity power plants and the direct use applications should be spread over all over the country, especially in the middle and the eastern side of Turkey. So we started our study in the Eastern Anatolian region with low to medium temperature geothermal sources around the Varto. As you see from the map, the study area is located in the Euphrates River basin. This is the longest river in its region, and which has a population of approximately 23 million of people living in there. In addition to very important water resources, there are 87 geothermal springs and nearly 18 geothermal wells with different temperatures in this area. In our study area, there are 3 important geothermal fields. These are KAYNARCA, GUZELKENT, and ALTERATIONS geothermal fields. There is also one low-flowing geothermal spring, namely Abdurrahman Pasha, and 2 mineral water springs, Karameşe and KAYNARCA. Now you can see the stratigraphical and the hydrogeological units in the study area presented with a columnar section. As it's now for us the most important of all these geological units for geothermal system are the units that can form a local or widely distributed reservoir, an aquifer. So our quaternary basin units can supply a significant amount of water for only drinking wells. However, the main reservoirs are the main reservoirs of the geothermal system are the fractured volcanics and the basement rocks. When we look at the basement rocks, Bitlis metamorphics are important reservoir in eastern Anatolia. So this unit has karstic structures, solution cavities, veins, alteration zones, and strike slip faults allow the water circulation and create some important networks for groundwater movement. And also they can form cold water springs in this basement units. And the second one, the fracture systems are the secondary structural elements that control the fluid circulation in volcanics, and especially in the Solheim volcanics. Our previous studies have shown that these fracture systems are concentrated especially around the domes, seals, dikes, and volcanic centers, and with some local extension zones. In the field, especially in Solheim volcanics, we determined some alterations like woody silica and some weathering and alteration zones in limestones and in travertines. In addition to the structural controls, some stratigraphical factors affect the fluid circulation in the geothermal systems have also been determined by us. The most important of these are dikes, seals, and tilted limestones. All of these structures can be a barrier, conduit, or a flow channel for our geothermal fluids. The Varto fault zone is located in the East Anatolian contractional province, where the compressional regime and collision-related deformation are dominant. The most important tectonic features in this region are East Anatolian fault zone, North Anatolian fault zone, and the three segment of the Varto fault zone. When the structural controls in the region are evaluated on the deformation ellipsoid, the faults, all of the cracks, the secondary structures in the geothermal fields are compatible with the stress regime and the deformation pattern in the region. However, we can see the effect of compressional and the extensional tectonics together with the dextral strikes in the Varto fault zone. The main reason for this, I think, it's thought to be due to the periodical changes in the tectonic regimes in the region. In terms of structural geology, we can see this situation in the bending and step over zones due to the movement of the strike slip faults. And since it's a strike slip fault, both transpiration and transtensional deformation can be seen in this fault zone. In the field, the main tectonic structures in the Varto area are northwest, southeast, right lateral strike slip faults, step overs, tool aparts, pressure and fissure reefs, and mostly the intersecting faults. When we look at the structural controls in our geothermal fields, in the GUZELKENT geothermal field, this field consists of 5 geothermal ponds of various size of fluid temperature up to 33 degrees Celsius. And GUZELKENT's hot springs are naturally exposed along the Mengel River bed, which is affected also by the deformation of the Leylekdağ segment. And previous studies show that the Leylekdağ segment is an active northwest trending dextral strike slip fault with some minor reverse component. However, deep-seated strike slip fault segments caused the deformation in this field, in this bending region, and formed a local transtension zone so that our geothermal fluids can easily reach the surface via these fault segments. As you see from the image, northwest trending dextral strike slip fault sets, which are synthetic with the Leylekdağ segment, are the main controllers. And these fault segments have nearly vertical fault planes. In addition, during the study, normal and strike slip fault planes were determined in the Yolüstü formation around the Varto settlement. The second geothermal field is the Alagöztepe geothermal field. This field is located in the eastern part of the Leylekdağ and the Çayçatı segments. The springs are located on the ridge, bounded by the Goşkar River in the south. There are 2 important hot springs in the field, and their temperatures are between the 28 and 35 degrees Celsius. So this region has an essential fissure-rich travertine formations in terms of geothermal hot springs. The geothermal fluid reaches the surface along the fracture tip on the fissure ridge and also in the extensional cracks on the travertine slope. The directions of the fractures are compatible with the approximately north-south compression region in the region, and they are all product of the local translation moment. And you can see the travertine formations in the Alagostepe geothermal field. And the last field is the KAYNARCA geothermal field. This field has a hot spring with temperature of 35 degrees Celsius, and it's located in the stream bed in KAYNARCA village. You can see the KAYNARCA village and our hot spring. The geothermal source morphologically emerged in the fault intersection area between the KAYNARCA and Çayçatı fault segments. The approximately northeast trending faults and the KAYNARCA river valley and the antithetic and the sympathetic faults of the segment intersect along the stream bed and form our geothermal system. In the south of the hot spring, northwest trending strike slip faults step over and affected the morphology of the KAYNARCA river. And also they form some small-scale two apart basins in the study area. When we look at the hydrogeochemical properties, one of our physical parameters, the electrical conductivity values of our geothermal fluids are higher than the cold waters. Also, our results show that sodium and chloride concentrations in the hot springs are higher than the cold waters and cold springs. This situation reflects that the deep circulation and the longer water rock interaction. And in addition to this, our isotope studies in the region has shown that the geothermal fluid has a deep circulation. When you look at the Schöller diagram, the trend of the water nearly show the same trend, the same distribution. And this reflects the recharge and the feeding from the similar or nearby aquifers. And according to the anion and cation distributions of the samples in the Piper diagram, the cold waters are of the calcium bicarbonate and mixed type. The geothermal fluids are sodium chloride and mixed type. The mineral waters are of calcium bicarbonate and sodium chloride type. And these are our results of the study. In the Varto Basin, the fractured volcanics are primarily responsible for the secondary permeability. Geothermal fluids moving along the deeper levels via these strike slip fault segments of the Varto fault zone. While GUZELKENT and Alagostepe geothermal springs formed in transtensional areas where the strike slip faults segments bend and step over. The KAYNARCA sources under control of secondary fault segments that intersect with each other and the main KAYNARCA fault segment. There are also fissure-rich travertine formations associated with faults in the Alagostepe geothermal field. There are important hot, cold mineral waters in the region that will gain importance in the long term. The use, security, and the protection of these resources are very important for our country, I think. The unused resources in the study area, and especially in the Eastern Anatolia, should be determined, and investments should be made for direct uses such as district heating, greenhouse heating, aquaculture, thermal tourism, health tourism, and that may be all beneficial for the local people. And with this study, I think the interest in the geothermal resources in the Eastern Anatolia, especially in the Muş, Varto, Bitlis region, has increased. So in addition, as a result of this study, the geothermal fluid with temperature of 40 degrees Celsius and a high flow rate was obtained with drilling carried out in the Alagostepe last year. Thank you for listening to me.
Thank you, Dr. Uzelli, for this very nice talk. So I guess there are some comments and questions from the audience. Now the paper is open to questions. Any question or comment? I have one question, Taygun. So thank you again. You already touched in your presentation, but I want to hear your detailed comment about the following point. Do you see any benefit to public, to domestic people out of your project?
I can say our study is the result of my PhD and our project in the Moshe University. So this study can be seen as a pre-feasibility study. And I think in this region, we need more research on geophysics, geochemistry, geology, and also we need some investment. We need new gradient and researching wells in this region. So when you look at the geothermal potential of the region, for example, the direct use potential of the region, I think that this potential is very high. There are lots of geothermal sources in the region. For example, I'm thinking about this. The climate is different in this region when you compare with the other regions of the Anatolia. The weather is very cold, and I think the people needs heating applications in there. For this reason, even low temperature geothermal sources can be used for the residential heating. And maybe these developed zones can be used for snow melting of the roads. It can be a useful solution for the closed roads because of the snow. I think there are lots of potential in there. Maybe in the eastern side of the study area, especially around the Nemrut and Van region, there are some high temperature sources in there. Maybe we can use this source for electricity production.
Okay, thank you very much for the comments. There is one question. Do you see hot springs near to volcanic lakes?
We cannot see in Varto region, but you can see these sources, especially around the southeastern side of our study area in Mush Basin. There is a Nemrut caldera in there. You can see these volcanic lakes in Nemrut caldera. So this quaternary volcanism affect this area, but you cannot see in Miocene volcanic region in Varto Basin.
Okay, and there's one demand to share your thesis with one of the attendees now. Then I will share you later on. Okay. Any more question or comment to Taygun Uzelli, Dr. Uzelli?